What is ideal gas equation and derivation of formula for ideal gas equation? So what is ideal gas? In the previous video we explained, so you can see and understand in the form of short video. Now what is ideal gas equation? The gas equation which shows the relationship among the pressure, volume and temperature of the gas when three are changed is a ideal gas equation. So the ideal gas equation shows the relationship among pressure of the gas, volume of the gas and temperature of the gas. So let 1 mole of gas is taken. Initially its pressure is P1, temperature is T1, volume is V1. So let the pressure is changed from P1 to P2, keeping the temperature constant. Then volume of the gas also changes. Let from V1 to V, the change in volume. So you can see in the form of figure. So here initially it is a P1 and volume is a V1. Then pressure is changed from P1 to P2. Then volume is changed from V1 to V. But in both cases, temperature is maintained constant. Temperature is constant. So it means that pressure P1 is P1, V1 is V1, pressure P2 is P2 and V2 is V. That is initial pressure and initial volume, final pressure and final volume. From Boyle's law, so we know that from Boyle's law we derived the formula for Boyle's law. P1 by P2 is equals to V2 by V1. This implies P1 means P1, P2 means P2, but V2 is taken as here final volume V and initial volume is V. By the cross multiplication, P2 into V is equals to P1 V1. This implies then V is equals to P1 V1 by P2. This is equation number 1. So now from Boyle's law this is. Now we are going keeping the pressure constant. We are changing the temperature of the gas, that is from T1 to T2. Then volume of the gas changes, that is from V to V2. It is a case 1. It is a case 2. This part we have applied Boyle's law. For this part we are applying Charles' law. But here temperature is changed from T1 to T2, but pressure is not changed. So pressure is P2. No change. P2, P2. So keeping the pressure P2 constant, keeping pressure P2 constant, T1 is changed to T2. Then volume of the gas changes from, that is V to V2. So this implies T1 is T1, T2 is T2, V1 is V and V2 is V2. Pressure is constant in the second case. So you can see here in the second case. So now from Charles' law, so we know the relation between temperature, absolute temperature and volume of the gas from Charles' law. V1 by V2 is equals to T1 by T2. V1 means V, V2 means V2, T1 means T1, T2 means T2. So now by the cross multiplication, V into T2 is equals to V2 into T1 by the cross multiplication. Then V is equals to V2 into T1 by T2. So this is equation number 2. So from equation 1, V is equals to P1 V1 by P2. From equation 2, V is equals to V2 into T1 by T2. So in the equation 1 and equation 2, left side is V. So left side quantity same. And then we can compare right side quantities. So from equation 1 and 2, we can write as, that is P1 V1 by P2 is equals to V2 into T1 by T2. That is compared equation 1 and 2, as the left side is a V and V. So left side quantities are equal, then right side quantities will be equal. So compared. So this can be by the cross multiplication and changing the places of T1 and P2. So P2 is transferred to here and T1 is brought to here. Then it can be written as P1 V1 by T1 is equals to P2 V2 by T2. Suppose we are taking in 3 cases, then it will be P1 V1 by T1 is equals to P2 V2 by T2 is equals to P3 V3 by T3 is equals to P4 V4 by T4 and so on. So this implies it can be written as PV by T is constant. So this constant is taken as R, which is called gas constant. So for 1 mole of gas, the ideal gas equation is, by the cross multiplication, PV is equals to RT. Just to cross multiply, where R is gas constant, whose value is 8.31 joule per mole kelvins. For n mole of gas, suppose number of moles of gas here, n moles are taken. For n moles of gas, the ideal gas equation is PV is equals to nRT, where P is the pressure of the gas, V is the volume of the gas, N is number of moles of given gas, R is a gas constant, and T is the absolute temperature. So this gas constant is 8.31 joule per mole kelvins. So you can see again from top to bottom. So the gas equation is nothing but the ideal gas equation is nothing but the gas equation which shows the relationship among volume, pressure and temperature of the gas. On changing 3, so we can derive the equation for it. So PV is equals to nRT. This is the ideal gas equation derivation. You can see clearly. For 1 mole of gas, PV is RT. For n mole of gas, PV is equals to nRT.